Okay, here we are. So this is the ST808. As you can see, the instrument is here on my desk. I'm not using any kind of protection. I have no anti-static mat. I can touch the probe with my finger. The instrument is on, so absolutely no protection, to show you that you can take this instrument into any production environment and it will work just fine. So you see the 6 channels, the 2 10 gigahertz differential, 1 single-ended 10 gigahertz, 1 single-ended 20 gigahertz, and the 2 differential 20 gigahertz. So for this demo, I'm going to use the 20 gigahertz differential. I have connected a probe which is a 35 fixed mil differential groundless probe. Okay, you see differential, 2 cables going into the probes, and I have 2 pins on one. They are very small with a fixed pitch at 35 mils. But I have other probes available. This is a I don't know if you can see it, but this is a 25 mils fixed pitch probe. I have a variable pitch probe. You can see from these little wheels here that allow you to adjust the probe. And we are going to test these small PCBs. That belongs to one of our customers. Just to give you an idea, this small PCB, as you can see, is about, the traces are less than 20 millimeter long. The complete PCB is just over 20 mm. The traces are less than 20 millimeter, should be around 18 millimeter. And there are several differential lines into each one of these small PCBs. And just for example, we will test 2 of them. One will have a target impedance around 120 ohm, and the other one will have a target impedance around 85 ohm. Okay, so we are almost ready to go. Now, as you can see, I have split my screen in 2 parts. So here you can see the test we will do in real time, and on the left part here you will see the symmetric software and the results that we will get. I will use a magnifier lens, this one, because the pads to catch are so small that I can see them, so I need some lenses to be able to catch the pads properly. Okay, so we are set now, and now we are going to make a program to do this testing. Okay, so I already prepared the program, and now I'm going to open. I named it test video. So okay, this is my test program. As you see, I have 2 traces to test. Test number 01, trace number 1. I can show you his target impedance under than 20 ohm. I'm using differential 2, which is the 20 gigahertz channel, differential channel, and the test number 2, which is an 85 target impedance, also using differential 2. What you see on the screen now, as you can see, we have a blue line. This blue line is the end of probe. So everything on the left side of the blue line is inside the probe, and everything on the right side of the blue line is the trace I'm going to measure. And as you can see here, where we have a millimeter, I have set a display of a 25 millimeter. So you will see the trace will be no more than 25 millimeters. As you remember, we are running below 20 millimeters, around 15, 18 millimeters. And here we have the home. I'm sure you are quite familiar with this kind of display. Okay, so let's start, and we try to do our first test, the 120. Okay, so as you can see, I moved the camera so you can have a better view. And now I'm trying to catch these pads, which are really very small, and I hope to catch them. If not, I will try again. Okay, we have been lucky, so we got the first test. As you can see, this line was very short. It's about is end around here, so it's about 18 millimeter, and we have no ripples at all. This is inside the probe. Okay, so the probe is about 100 ohm, is going up, and then this little bump is due to the contact between the probe and the pad, and then we have a very, very flat signal, even in such a short line. Okay, so this is the kind of results you are getting with the 808. Let's go and test the second line now. Okay, so now let's go and test the second line. So it is even more difficult than the first one. Okay, so we try. I hope I'm catching. Yeah, let's try. Oh yeah, we have been lucky. Okay, so you see, this is the second trace. I also save it. Okay, so I have my two traces now, and I can have a look to them. Okay, so now let's have a look, a better look to the traces. I just open the complete screen so I can have a better look to what I'm seeing. So we did two tests, test number 1 and test number 2. As you can see, I still have the complete waveform, and this waveform will be saved completely. So the first one was around 120, as I told you, and we have here the inside part of the probe. Then the impedance is going up to reach almost the value of the trace, and I have a very, very clean signal. And same is for the other, for the 85. In this case, you see the probe is dropping down. This is the bump, also due to the contact between the probe and the pads, and then it's going down to about 85 ohm. It's less than 80, but around, I was expecting a value around that. So it's going down. So you can see how flat and how there are absolutely no ringing, no ripples. So we have a very, very clean signal, even if we are, please note, 25 millimeter is here. Here is 0, here is 25. So we are running something that is less than 20 millimeter in this case. So this is a kind of quite difficult board to test, which for sure will give you problem even in case of using a Tektronix or an Agilent instrument.